My solutions and just brief explanations of my solutions to the projectile homework problems. Hopefully you did pretty well on these since the answers were given. So essentially you can use 9.8 or 10 as your gravitational acceleration. I tend to use 9.8. So for all these, we're going to assume that the object is a projectile, meaning gravity is the only force acting on it, and we can ignore air resistance. So we've got Dylan and Sophia, Buckeye Lake. He wants to skip a rock to impress her, gives it a horizontal velocity of 26 meters per second and a height 0.45 meters above the water surface. The time it takes the water to fall, or the rock to fall to the surface, does not depend on its horizontal motion. Horizontal and vertical motions are completely independent with projectiles. So I'm going to think only about the vertical motion. Since it starts with 0 vertical velocity, I can use this version of my motion formula, and I end up coming up with a time of 0.303 seconds. When I then go and think about figuring out how far from the edge of the water the rock travels, I'm going to use that time that I got here and multiply it by the horizontal velocity, because horizontal velocity for projectile doesn't change. So this is the only formula we have, along with rearranging it, for horizontal motion for a projectile. So that comes up to about 7.9 meters. For PC22, I'm sorry that I used someone different last year, so we'll assume that Saran and Matthew are the same person. I know that's odd. Anyhow, similar situation as what we had before. Saran is leaving the high dive at 4.6 meters per second. I'm going to assume horizontally, and then falls in 2.3 meters down in the water below. So this is the initial information. To find the time to fall, I'm going to use this equation again. Don't know why I didn't put an in parentheses there. It comes out to about 0.69-ish seconds. So then the horizontal distance, I do the same thing. Figure out that it's moving 4.6 meters per second horizontally, and it's doing it for the amount of time I figured out up here. So it ends up, the student ends up 3.2 meters from the edge of the diving board. Now this one, I went over a similar example in class. If I want to find the speed that Saran entered the water, then the final speed that Saran entered the water is essentially I need to find the vertical and horizontal components of speed. Well, horizontal doesn't change. Vertical starts at 0, but the vertical speed increases 9.8 meters per second every second, as we've seen for a while now. So since I know the time up here, I'm going to use this version of a formula that we have, and I don't need an initial velocity. So acceleration times time. That means my final vertical velocity is 6.7 meters per second down. So the overall speed is a vector resultant of the horizontal and vertical components, and that's about 8.1 meters per second. Going to the back side, this is the final one that's a horizontal problem. So do the same thing again to find the time it takes to hit the floor. This would differ if we had an initial vertical velocity. So if that was true, then I would have to use the delta y equals VOT plus 1/2 AT squared, and I'd have to keep track of whether the initial vertical velocity was up or down to determine whether that's the same or opposite side as acceleration. In this case, I'm thinking of down as positive, so it takes 0.48 seconds to fall. I did need to convert the centimeters to meters. Otherwise, I'd have to convert acceleration for gravity to 980 centimeters per second per second. I know the horizontal speed, so again, doing the same thing, figuring out the horizontal distance. And then this is very similar to what I did in the last problem. To get the overall speed of the French fry striking the floor, I need to find the vertical component of speed just before it hits the floor, combine that vectorially with the horizontal component of speed, and I get around 4.9 meters per second. This one you could tell I screwed up. I had labeled these incorrect, so that's why I did some math wrong. So first thing for this, which is a projectile going up at an angle, I find the vertical and horizontal components, so that's using trigonometry and vectors. Make sure you're in degree mode. So horizontal is cosine, 6.98 meters per second, vertical velocity, 4.03 meters per second. So even though this is 8.06, there's less horizontal and vertical as the components. Remember, the optimal angle for shooting to get the maximum distance for a projectile is 45 degrees if the projectile lands at the same height as which it's launched. So to calculate the time to reach the midpoint, there's a few ways you could do this. Obviously, you need an acceleration equation and you need something with time. I chose this one. So I know that the vertical velocity initially is 4.03 meters per second, and it should be 4.03, not, oh, I said 0 minus 4.03. Using the absolute value there because we can't have negative time. Otherwise, I would have to put this as a negative, whatever. Anyhow, you could think the first or second half of the trip. So basically, that change in vertical velocity is 4.03 because at the tippy top, there is no vertical velocity. So that's 0.41 seconds. The total time in the air would be the time up plus the time down. That's double the time up or the time down. And then the horizontal distance, I take my horizontal velocity, which I figured out up top, and multiply it by the total time. So that gives me 5.72. It says calculate the height of the egg when it's at its peak trajectory. So at this point, I know that the time to get there is 0.41 seconds. So I could use other ways to do this. I could use delta y equals 1/2 at squared and figure that out. Or I could think of either the time up or the time down to figure it this way. But either way, you've got to use an equation with acceleration because that's what's acting vertically, and we're talking about a vertical height. Hopefully these help.